Hi, everyone. Thanks for joining. We'll start in a minute or two.
Hello.
Hi, Stephen. I was going to ask you to check your audio, but you already did it. Thanks.
Hello, everyone. We'll just wait another moment or two. I see attendance is still ticking up, so it'll just be another moment. Meredith, I see some messages in the chat about a password. That did not happen to me when I logged in. Do you know anything about that?
There shouldn't be, but let me just check my calendar. Hold 1 second. So there's a meeting ID and a passcode, but was that not included in the reminder?
Like some people are putting a passcode in the chat. I guess it's asking sometimes and not asking others. It did not ask me.
Yeah,
and 300 other people managed to make it on, so I assume.
So I don't know if someone is in contact with someone who can't get in. I guess they can send them the 838-54960.
All right, and Stephen, do we have Les on the line?
He had just messaged he's most likely not going to be able to join today now, so it'll be
okay. Then we will not wait further for him. So without further ado, welcome everyone to the final installment of ClinGen's Summer Workshop Series. Today we are joined by Dr. Stephen Harrison, who's a board-certified molecular geneticist working as a laboratory director at Ambry Genetics. And he is going to be presenting to us an overview of the ACMG AMP version 4 sequence variant guidelines. So, Stephen?
in here. Oh, right. Hopefully you all can see the right screen here. So yeah, thank you everyone. Today I am presenting here on behalf of myself and Les B. Seeger. We are the co-chairs for the next version of the ACMG guidelines on sequence variant classification. And I have a small link here at the bottom, this tiny URL where I've uploaded these slides as well as some of the draft decision trees that we've been working on that are available so that people can look at these after the fact as well and be able to give us any feedback as you're thinking of it. So a little bit of background here. Let me move a little out of the way. There's a little bit of background here talking about the different versions of the variant classification guidelines. So most of us are familiar with the 2015 guidelines, the Richards et al. But prior to that, there were 2 other versions from ACMG for sequence variant classification that came out in 2002 and 2008. So this next one will actually be sort of the 4th version. And so we've decided now to retroactively call those prior ones versions 1, 2, and 3. And this will allow us now going forward to better reference what, again, version of guidelines we're using. But also by bringing in versioning, we can also do smaller updates. For example, there are certain types of data that maybe we're not quite ready to give good recommendations about at this point, but maybe a year from now, we would be able to update and say, now here's better information about non-coding variants. So that could be, a 4.1 update to be able to make smaller changes like that. Additionally, we're working to collaborate with the ACMG ClinGen CNV guidelines. So with the 2020 version that had come out from of the CNV guidelines was where the terms were now harmonized between sequence variants and CNVs about saying, pathogenic, likely pathogenic, VUS, and such. That 2020 guideline also used a points-based approach. We will now also do a points-based approach in the next version of the sequence guidelines. However, it will not be the exact same point approach. So now the CNV group is also working on a next version where we'll harmonize our points so there's not 2 different point versions that labs have to use, one for CNVs, one for sequence variants. So as many of you know who have used the 2015 guidelines, while they definitely were a huge step forward in the field, there definitely was a few limitations with these guidelines, that there were, there's a lot of subjectivity in applying different pieces of evidence, and there weren't clear rules about if you're using this type of evidence, don't also use this type of evidence. And so we wanted to, for the next version, be able to be a little more prescriptive about, if you're going down this path for this type of evidence, here's what you could use or not use, to have a little more sort of logic and decision trees going into the process. So after the 2015 guideline had come out, the ClinGen sequence variant interpretation working group has been working on general recommendations to help with consistency about how we're all approaching applying these rules. So you can see here's a screenshot from the website where we've been posting the general recommendations as we have them available. And much of this work will now be incorporated into the next version of the ACMG guidelines, that a lot of these work we've done to sort of help with consistency and make it clear when to move weights of evidence. That sort of logic is what's helping educate our next version of the guidelines. Additionally, we've been working a lot with seeing how different VSEPs have been approaching the guidelines and what specifications they've done. A lot of VSEPs have taken the same approach or have all modified or specified criteria in the same way. And so that shows to us that, if everyone's making the same changes, we should just make that more of a global change. And so being able to, work with the VSEPs and be able to see this data is also hugely helpful to our work we're doing on the next version of the guidelines. Additionally, just as a sort of caveat here, one part of the 2015 guidelines that it didn't really touch on is what to do with low penetrance and risk alleles, which is something that we also won't be tackling in the next version of the guidelines. However, there is the low penetrance risk allele work group in ClinGen, which is working on a manuscript for terminology and how to classify these variants. And so we're hoping that this manuscript, along with the next version of the guidelines, will help give better clarity about how to approach and classify these, lower penetrance or risk type of variants. So here's our current work group. This next version, V4, in addition to being ACMG and AMP joint guideline, is also now CAP and ClinGen, our partners in this next version of the guidelines as well. And again, here's our membership in the work group here. So overall, our sort of scope as we've been approaching this is to look at the 2015 guideline and look at what were the inconsistencies and how people are applying different pieces of evidence. And a lot of this comes again from SVI and from looking at VSEPs about how they've been doing different gene-specific or general specifications to the guideline. And we were tasked with overall looking at a more point-based approach for the guidelines. We're continuing with the scope from 2015 as far as when these guidelines would be applicable. So these rules are still applicable for when you're looking at a variant in a gene that is known to have a role in a disorder. this approach is independent of the testing platform. So whether it's single gene, multi-panel, exome, genome, healthy, affected individuals, you would still use this guideline for classifying those variants. And additionally, we will reiterate the point from the 2015 guideline that pathogenicity determination, or classifying the variant, is independent of interpreting the cause of disease in a given patient. That you could have a pathogenic variant in an individual, but it maybe doesn't explain their phenotype, in the same way that they may have the strong phenotype. You didn't find a pathogenic variant, that doesn't change the disease in that given patient. So looking at sort of one of the first changes that we'll be incorporating into the next version of the guideline is this concept of bringing in the gene disease validity into variant classification. So showing here on the left the different gene disease validity terminology, and then at the top the variant classification terminology. So what we're gonna suggest is that for if you're classifying a variant in a gene that has a definitive or strong role in disease, that in those cases you can use the full spectrum of classification terms from pathogenic to benign. However, once you get down into a moderate gene disease validity level, at that point, we'll be suggesting that on the pathogenic side, you limit to likely pathogenic. So if you're with this next version, we're doing with this point approach, even if the points add up to pathogenic, we still think you should call the variant likely pathogenic as opposed to pathogenic, just to have that overall caveat about the fact that this gene disease relationship is still a little uncertain, and there is still emerging data about this. Additionally, if it is a limited gene disease relationship, in those cases, we feel like we shouldn't be going past calling something a variant of uncertain significance, that those variants shouldn't be reaching likely pathogenic or pathogenic, because there's still just too much unknown about if this gene really has a causal role in disease. And then additionally, if there's less than limited evidence in those cases, it's a variant in a gene of uncertain significance. And then for variants in refuted or disputed gene disease relationships, that we don't think variants in those cases should be reported, and so they shouldn't be classified. So sort of where we are right now with the general framework going forward is, again, we are taking a point-based approach, and where these points come from was this initial Bayesian framework of the 2015 guideline that was published in 2018 that looked at the different combining rules in Richards et al., and then what the definitions of likely benign are, and was able to then backtrack to see what would the odds be of these different evidence strength levels, which led again to sort of this spectrum you can see here from benign to pathogenic, with 1% probability of causing disease on the benign side, 99% for pathogenic, and then was able to determine these different odds of pathogenicity for the different evidence strength levels that were in the 2015 guideline. Since this is obviously a very math-heavy approach using these, and that not all lines of evidence are really have enough data to be able to determine what the odds are, or be able to combine these as easily, in a subsequent update paper in 2020, this points adaptation was recommended. So instead of having to use a Bayesian equation every time to classify a variant, if you use these point equivalents or this point adaptation, that you could then combine this way and just use simple addition, subtraction to reach the classification levels here. So you can see with this approach, benign would be at -4 points or low, likely benign, -3 to -1, uncertain 0 to 5, and so on. And so you could even look at what, for any current variants you have that were classified with the 2015 guideline, be able to look at what are the different pieces of evidence that applied, what was their weight, and be able to convert it to numbers and sum, and see what the the classification here would be, which would work with all the combining rules except for 1 or 2. So this is the overall sort of starting framework that we're using for the next version of the ACMG guidelines. This point scale from benign to pathogenic, and as we're sort of taking pieces of evidence from the 2015 guideline and bringing it into the next version, we're looking at what the equivalence would be in the points, and a lot of them will be starting at a similar point level within the next version. So one of the changes you may have noticed when I was showing this is, while we are keeping the definition of likely benign, which is 10% or lower chance of causing disease, the amount of evidence that it would take to reach that will be different than what was in the 2015 guideline. So here we're saying that reaching a point of just having -1, that this would be sufficient to call a variant as likely benign. So this is equivalent to, in the current framework, just a single piece of benign supporting data. And again, this is your sum of all points. So if there was any pathogenic points, those would be, you'd be back out of -1 into likely the uncertain significance. This is, you did assess all your data. In the end, you only have, data suggesting likely benign. You have at least -1 points that these could be called likely benign. Which again, compared to the 2015 guideline, you would have needed at least 2 pieces of benign supporting data to reach that. So this will be one of the sort of the overall bigger changes, I think, about how labs and VSEPs are approaching the guidelines of keeping this part in mind. This is something we're also, would be getting feedback on when we start doing the piloting to see where the, sort of variants around, this, part of the spectrum, where they end up. So this is something that if you feel strongly about, feel free to reach out or, be involved in the piloting here. So another change that will become because we can now be moving towards a point approach. This will allow us this option to subcategorize variants of uncertain significance. And the reason for this is, the uncertain significance covers such a wide range of probabilities from 10% chance causing disease up to 90%. And so not all VUSs obviously are created equal. There are some that have a lot of pathogenic evidence but don't quite reach likely pathogenic, or you could have a VUS that only has benign data or no data that's pushing you towards the other way. And so we wanted a way to be able to better call out which are those really suspicious VUSs that are likely to be causing disease, but there's just not quite enough evidence for us to call it likely pathogenic or pathogenic. So what we're going to be recommending in the next version is that laboratories start at least tracking using these subcategories, or being able to use the points for VUSs, so that we can get more data about how often these change. How often does a VUS up in the high range get reclassified to likely pathogenic over time? And how often do the lows move downwards? So again, we won't be recommending that labs need to start reporting using this terminology at this point, but more so that we think it would be helpful to at least start tracking this information. And there is a new ACMG committee that has been formed to come up with better guidance about when to report VUSs and when would it be appropriate to maybe only report certain subcategories versus others. So again, our next version of the guidelines will be point-based. It won't be, all the points won't be an exact match to how they are in the 2015 guideline, because we now have more, there's more point options for us to be able to select. But additionally, we will not be using the same evidence code. So I'll be showing on the next slide what these look like. And we were very specific about this, that we didn't want to use the same codes from the 2015 guideline, because we wanted to be able to make it clear when someone was looking at a variant and looking at the evidence that was applied, to be able to tell what version of the guidelines were used. And so we wanted to use codes, new codes, to help make that a little more clear. All right, so this is just my caveat that on the next slides, things that we're showing, these evidence codes and the point values, are all still draft at this point. So overall, how we're structuring the next version of the guidelines is currently we have 3 different sort of general buckets of evidence. Population data, seen there on the left, clinical evidence, so case observations, segregation data, Denovo occurrences, and then molecular impact evidence. So, is the variant predicted to undergo NMD? Is it a missense variant? So within each of these different categories, you can see, so we have sort of that first term, which is the bigger bucket, like CLIN or IMP for impact. And then within each, and then below each type is the more granular pieces of type of evidence, like missense, synonymous, and so on. So overall, what you'll see is, compared to the 2015 guideline, the codes that we're proposing are more descriptive about what is that line of evidence you're using. And the code itself does not tell you about whether or not the variant is contributing, pathogenic or benign evidence. And instead, the code itself just tells you what the evidence is. That the weight then comes from combining the proposed code with a point value. So, for example, a Denovo occurrence with a +5. Or sorry, +4 here. So that means you're giving 4 points towards pathogenicity here. And then to help determine where the points come from, we're working on different decision trees that would guide you to what the applicable amount of points are. Additionally, by using codes that are more descriptive about the pieces of evidence, we felt like this also will help that, codes won't be restricted by variant type. I'm sorry, 1 second. I'm watching my brother's house and someone's ringing the doorbell. One very, very quick second.
Anybody want to tell a joke in the interim?
No, but ClinGen, we're going to have to remember about the Zoom limit of 300 when we're talking about
300.
V4.
Oh, so is it?
Well,
Sorry, did it reach a limit? Oh.
There's a
Yeah,
300
it reached the 300 limit, so there's a lot of people who can't join, but it is being recorded and we can send it out after.
Oh, perfect. All right, so, and I think, sorry, the little Zoom thing's in the way here, but yeah, so at the bottom, again, is this link here, because on the next slide, I'll be showing some of the decision trees, so if you want to follow along or look, here's the link to look at those. All right, so as an example for how some of these decision trees would look, here's an example for a nonsense variant decision tree. So some of this overall structure that we're going with is, here for this nonsense, that first decision about whether or not the variant would be predicted to undergo NMD or not. And then you would follow down these different paths where you look at the exon transcript and then other informative variants that could be there as well. But the first part to kind of point out here is you'll see from going down these two different branches, the endpoint codes, so here this NMD or CDS, are different. And that's again because we wanted the codes to better reflect what type of evidence you're actually using. So for example, if we use just a code that said LOF, in a way that could be misleading because let's say you're going down the non-NMD route, and in the end, it truncates the protein by like 2 amino acids. So to really say that that's a loss of function, again, could be misleading because maybe that's not actually what the impact is, and it isn't actually causing a loss of function impact. We wanted the code to be a little more descriptive here. So again, sort of NMD, and then CDS here is we're using just to show coding sequence. So additionally thing to point out here is if we're following this top path of the nonsense variant predicted to go and undergo NMD, if this exon is present in the in the relevant transcripts, then in this case, you'd be getting 7 points. And I should have included the point scale here, but 7 on its own is enough to be in the likely pathogenic realm. So this is similar to the PBS1 concept right now, that concept puts you into the likely pathogenic realm. But we're adding on this new concept that if there are other known path or likely pathogenic variants in this exon that help you indicate that this exon is not being spliced out of any tissue relevant or transcripts that are tissue relevant that could be causing disease, that you could add on additional points here. So we're allowing a max of nonsense and frameshift variants that meet this scenario to get up to 10 points. And 10 is sort of the bottom rung for being in the pathogenic range. So this change will allow variants, nonsense or frameshift variants that are predicted to undergo NMD to be able to reach pathogenic as opposed to likely pathogenic. So that will be a change as compared to the 2015 guideline, where novel nonsense or frameshift variants sort of would have maxed out at the likely pathogenic range. So another example of a decision tree here that we've been working on is the allele frequency approach. So for this, we are sort of taking a little more of a choose your own adventure route here to decide what your applicable threshold should be. You could go with a very simple binning approach where you're just looking at overall what's the prevalence, what's the mode of inheritance, and it's a very generic approach. You could use a prevalence approach where you're using estimates of prevalence, heterogeneity, and penetrance to be able to come up with a threshold, or this pathogenic variance approach where if pathogenic variants would be found in population databases, so for recessive diseases or adult onset diseases, you could look at what the most common pathogenic variants are, for example, in NOMAD. And whichever approach you would take, in the end, you would be able to use a number that we're calling here your disease allele frequency threshold, and then any variant that you are assessing once you have this threshold, you would compare it to that, and it is how much over that threshold is would determine how many negative points you're getting for that variant. So for example, I think I have one here, yeah. Like for example, the most common MY7 pathogenic variant, I got this from looking across Nomad, has this allele frequency here of 0.0136%. So if I was assessing a variant, with allele frequency of 0.00035, it would fall into this bucket that it's at least 1x higher than this number, but less than 3x, so I could get a -1, and so on here. And so one thing also that you'll notice as we're looking here at the allele frequencies is that this first rung, this consistent with the allele frequency of path or likely pathogenic variants in this gene, is giving 0 points here, this pop frequency 0. So this is sort of the equivalent of the PM2 from the 2015 guidelines, but this contributes 0 points. We are having this concept be a prerequisite to be able to apply other codes in the different sections. But it on its own, or even in combination with those other pieces, isn't evidence. That's why we have it here as a 0, that it doesn't actually contribute any pathogenic evidence. So again, this concept of PM2 won't be in the next version as far as contributing any weight. But we are accounting for this with a few other changes. For example, when I was showing the loss of function variants, that those can now reach a higher weight if it's in a well-established gene or exon. We're allowing more computational weight for splice and missense variants, and we're also allowing patient phenotype to get higher weights than before. So this will help counteract some of the initial impacts that we might see from simply taking away PM2 as compared to how people are using it right now. So for a few other decision tree types for specifically missense and proband data, I thought it'd be helpful to have just an example variant to walk through to show how these would be used, because the missense tree is a little complicated at this point, so I thought having an actual variant could help. So the variant that I'll use in this next few slides, I picked the CDH1 missense variant here. So we'll talk about the predictive and other variant parts when I get to missense, but let's just, for this first part, look at this variant is absent from Nomad, and let's say it was found in 2 probands with diffuse gastric cancer, and in one of those cases, this variant did occur de novo. So for this first step, since this variant is absent from Nomad, looking at the allele frequency, I'm going to give it this pop frequency 0 applied because this variant is within what I would say consistent with the allele frequency of path or likely pathogenic variants for this gene. So I next can move on to the proband part. So here we'll be looking at how much weight to give each observation. So we have 2 probands here, and then is there any additional weight we would give for de novo? So this is sort of the base matrix we're working right now for probands, where we have this first section based off the phenotype consistency for your gene disease, and then for the cases you have as well here, and then the points for proband, whether it be a dominant disorder here, or if it's a recessive disorder, looking at what's in trans, is there another pathogenic or likely pathogenic variant in trans? Is it confirmed in trans, assumed? Is it homozygous? So this section here is similar to the PM3 concept in the current guidelines, with this dominant disorder being more similar to the PS4 concept. So we're kind of combining these into one just tree that you could use depending on, again, if your disease here is dominant or recessive. So let's say in this case, again, I have 2 probands that have diffuse gastric cancer. In this case, let's say I think that this counts as phenotype specific for the gene. Other relevant genes, have been tested or ruled out. There's no variance in those. So in this case, I'm going to give a +1 to each one of these cases. So far I would have +2 points under this case observation bucket. But additionally, this proband 2, the variant also occurred de novo. So this is the de novo matrix, and you can see this phenotype consistency column here is the same as it was in the proband counting. So consistency here for a sort of where you would select your proband to fall. And then, the weight, depending on if it was a de novo with confirmed parental relationships versus unconfirmed. So sort of that assumed de novo concept here. So in this case, because this variant did occur de novo and was confirmed parental relationships, I'm going to add an additional 3 points for this case here under this de novo code. So in the end, for the clinical evidence, each proband did contribute +1 towards just the overall case observations. And then I got another 3 points because one of the probands was Denovo. So I'd have 5 points total here coming from this clinical evidence. Additionally, we are working on a framework that I didn't want to put in here yet because it's still a little bit in flux of being able to increase the weight higher when you do have probands that have a very specific phenotype for that disease. When it is a really high diagnosis yield for that test and that phenotype of being able to go up higher than what we have here. All right, so the next step for this variant here, this missense variant, is to go through the missense decision tree. And I'm going to zoom in when we go through the different parts here, but just zooming out overall for this missense decision tree is there's 2 different branches here looking at the actual protein change, the amino acid change up here on the top rung, and on the bottom looking at if there is any splicing impact. And for both cases, sort of the first step is looking at the variant impact itself, looking at the predictions either for the protein change or splicing. And then the second step is looking at any other informative variants. So similar to that PM5, PS1 concept of seeing, is there other changes that either at this nucleotide or this codon or the splice site that could be used to support that this variant could be causing disease or not causing disease. So we'll start by going down the protein change part of the tree here first, so this first rung. So the first step is we're going to look at the different predictors, but we feel like it's important to first see if the residue that you're looking at is in the relevant transcripts, because if you're looking at a exon that is maybe not in the clinically relevant transcript, we don't think it is then applicable to be able to be applying in silico weight at such a high level if this exon is not even present in relevant transcripts. So in this case, I've highlighted where this exon is here. It is in the relevant transcript. This is the main select transcript here. So we are good to move on. And for this variant, it had a Bayes-Dell prediction of 0.18. And this table here comes from the SVI computational group's paper about PP3, BP4 that was published a few months ago. So in this case, I'd already decided I was going to use Bayes-Dell. A score of 0.18 would fall into this bucket here of contributing +1 points towards pathogenicity. So then the next step is to look at any other comparative variants to see if there is additional weight. There is another missense change in this codon here. It has a higher Bayes-Dell score than the variant we're looking at. It didn't have any splicing impact. It's been found in just a single case of breast cancer. So I would say this other variant is a VUS. I'm not going to give any weight towards the actual variant I'm assessing. And then there's also a silent change in the same codon as well. So this also would not fall into any of the buckets here of being able to give additional evidence. So in the end, right now, all I have under the missense data for this variant is a +1 point, which came from that Bayes-Dell prediction. So next, we've gone through the top row here. Then next, we'll go now through the bottom branch here, which is looking at the splicing impact. So in this case, this variant had a pretty high Splice AI score, 0.91, and Splice AI is from a 0 to 1, with 1 scores closer to 1, suggesting a higher chance of an impact. Sorry, the thing's in the way. I can't see what's under here. Yeah, so we'll follow down this route that it looks like there is a splicing impact predicted. The next part is to look at what is the actual predicted impact, because you could have a high, splicing prediction, but for a relatively benign change, only, taking off maybe 1 codon from that exon, and it doesn't produce any kind of out of frame transcript. So we felt like, after you've looked at the prediction, you need to assess what that impact would be. So in this case, it is predicted to skip that exon, which is out of frame, so it would produce a frame shift. So I will follow down this route that it is predicted to disrupt the leading frame and would lead to NMD. So in this case, we're going to allow 3.5 points based off this prediction score and what the predicted impact of this change would be. And then similar to the missense, the next part is we'll compare it to any other informative variants that were also in this codon or here in this splice site. So again, there was that VUS here that, this one had splice AI score of 0. It was a VUS. There's nothing that would contribute here. But there is a different change at the same nucleotide position, the silent variant, that also has a high splice AI score for the same predicted impact. It has had RNA data that confirmed abnormal splicing and was found in multiple cases that have diffuse gastric cancer. So this other variant would meet pathogenic. And since it is at the same position here, nucleotide position here, and has the same splicing impact, we can add an additional +2 points towards our overall assessment of this variant here. So in the end for splicing, we'd be at 5.5 points here, 3.5 which came from the prediction and what the predicted impact would be, and another 2 points from having this other pathogenic variant at this nucleotide position. So in the end, we would now kind of compare. So we've taken this missense variant and followed it down the missense track, and then also down the splicing track, and we got only +1 point from missense, and we had 5.5 points from splicing. So in the end, I would only apply this splicing score and not the missense, and I also would not add these together. That in the end, we're suggesting you would pick out of these 2 scenarios, whichever is giving you the most pathogenic evidence. So in this case, I would have the 5.5 points coming. So for this variant overall, this missense CDH1 variant, when we look at all the points we've accumulated, this variant was absent from population databases, but that doesn't contribute weight on its own. We had 5 points total come from clinical evidence, 2 points that came from the 2 different probands, an additional 3 from having one of them be Denovo, and then also 5.5 points that came from the predicted impact and the other informative variant at that nucleotide position. So in the end, these would sum to 10.5 points. Oh, this is an error. This should say pathogenic, not likely pathogenic, because it does push you past 10 points here. So you would be in this realm, and this now would this variant could reach a pathogenic score. So sorry about that. I meant to update there. All right. So overall, what will sort of the next steps be? What would the impact be? Because we know there's a lot of a little bit of hesitation on the fact of labs and VSEPs about what will be coming. How is this going to impact what we've already been doing with the 2015 guideline? And so even though the codes are going to be different, the concepts from the 2015 guideline will still be there in the next version, just coded differently. So for example, right now when a VSEP or a lab is looking at how to apply the criteria based off phenotypes, they often are thinking, okay, how specific is this phenotype overall to have this case contribute to my PS4 counts or PM3 counts? What is the minimum amount of phenotype that's needed in order to say that a variant is segregating in a family? What am I looking for those phenotypes? That all this information goes into the decision about how to apply these different 2015 ACMG codes. But all these also will be used, for the next version, that you still would need this information to, be able to count something towards a case. Did it have a specific phenotype? Did it just meet some criteria, but it's not going to give it the same weight as someone who has, meets full diagnostic criteria, to count a segregation? What data do I need there to know that that case is affected? Or for a non-segregation, what, phenotypes need to be ruled out there? Additionally, even on the variant effect side, these same decisions will also be needed there as well. So, for example, with computational predictors, you first would have to decide: are missense variants even known to cause disease for this gene? Is it even appropriate to be using in silico missense predictors? Which one of these tools may be the most applicable for this gene? Additionally, on the loss of function PVS1 side, for variants that are not predicted to undergo NMD, VSEPs and labs look at what's known about that region of the protein. Is it a critical region? Would losing this, even it might be an in-frame change, would losing this part of the protein still have more of a literal loss of function impact on this protein? And so these concepts still, will be in that next version of, here's the, point equivalence of being able to determine this deletion does, completely encompass a known critical functional domain. And so I can give points here. So this gene level information and proband level information all still will be needed for the next version. So any work that you're currently doing to look at the ACMG guidelines is not in vain, that this information still will be needed as we move forward into the next version. So our timeline, this is definitely the question people are always the most curious about. We are hoping to complete a draft standard by this fall, and we'll be reaching out to laboratories to help get some feedback that as they sort of try what we have compared to what they're doing now, how do the classifications of these variants compare? Once that's done, we will then be able to submit a draft to ACMG to start the review process. It goes through a few committees at ACMG before it then gets opened up for full member comment from any ACMG members. Then it'll go back to us to incorporate feedback and go from there. So this whole process of, once we actually submit it to ACMG until it actually gets through and approved can take anywhere from 6 months to a year or more, I guess, depending on how much feedback we get. But this is just to point out that we have not yet turned it in. So it is definitely still at least 6 months to a year before, these would be finally approved and out for people to be able to start using. Additionally, we don't anticipate that as soon as the guidelines come out, everyone will be able to just move to them, that we know that it takes a lot of time for systems to get updated, for people to be able to move over sort of what they've been doing on the 2015 guideline into the next version. So, we know it'll at least take a year or more before labs are able to actually start implementing these new recommendations. And we are planning to, once we get a little bit further and have a publication date in mind, be able to start setting up training and workshops similar to when the CNV guideline came out, of doing sort of targeted walkthroughs for specific parts of the guidelines to give more detailed guidance for people to be able to know kind of when these are applicable or not. And then again, we are aiming to be able to do some incremental updates after we're able to publish this version 4.0, that instead of waiting 8 years between each version, we'll be able to again do some of these more smaller subsequent updates. And then if you are curious in or would like to participate in any of the piloting of the guidelines, we haven't yet started those, so feel free to email us here, and I can add you to our contact list for the piloting. And additionally, here is the link for if you want to look at any of the draft decision trees I showed today. Here's the link to be able to download those. I think that is everything. So we have plenty of time for any questions.
All right, thanks, Stephen. So just so you know, there are numerous questions in the chat, but I believe most of them have already been answered. So I'm just going to leave some space right now for anyone to come off mute and verbally ask another question. If we don't get any, I will start reading out some from the chat in case people didn't see them or want to comment further.
Hi, this is Jerry Machado. I'm not sure if you covered it earlier. Any updates on risk alleles and how that's being treated?
Yeah, so I had that in the one of the early slides, that there is a ClinGen low penetrance risk allele group that's been working on a manuscript to give terminology guidance as well as guidance about how to classify those types of variants. And I believe, I don't know if Heidi or Aaron, if either one of you know an update about if that, I know they had a white paper that was out that I think was more about the terminology, but I don't think they've published the guidance yet.
They responded to the first round of reviews, and I think that was sent in within, I agree, 2 weeks ago. Aaron, do you remember? A few weeks ago.
That sounds about right.
So hopefully it'll get accepted pretty soon and be out soon.
Sounds good. All right, thank you.
We do have a question. Do you want to talk about how this will impact variants that have already been classified by ClinGen using prior guidelines?
Yeah, so I mean, there definitely will be some classification differences from using this approach versus 2015, but we don't think it's going to be a massive change. Like variants that reach pathogenic now with the 2015 guideline should still be reaching pathogenic with the next version as well. And so at least for BSEPs, we're not going to be requiring that they have to go back and reassess every pathogenic variant that they classified with their current guidelines with the V4 guidelines that are coming out. That those benigns and pathogenics should be pretty stable.
But we do hope that in the piloting, as we see which types of evidence from the past and the present are leading to the most significant differences, that we could suggest groups search their systems for variants with those codes and preferentially, consider reevaluating based on those. Like certainly if you're applying PM2 at moderate level, you should reassess, for example.
Yeah, exactly. Yeah, that being able to look at sort of and that's what we're hoping, something to learn from the pilot of which are the variants that are most likely to move, and be able to address those better and give people guidance about that moving forward.
Yasmin has her hand up.
I do. Thank you so much, Steve, and the whole organizing group. I mean, this is so helpful. A quick question. What are the criteria to apply to be a laboratory that would help pilot? And if you could just comment a little bit on the degree of commitment. I think, our group here has certainly expressed, just in the last 2 seconds, expressed some interest at nationwide children. So if you can comment on how can we do this?
Yeah, so far, anyone who has said they would like to volunteer, I've been adding them to the list. There's no criteria you need to meet. If you aren't responsive to emails, then I guess we wouldn't include it after that. But yeah, anyone who's interested, we're happy to. As far as a commitment, at this point, we are hoping that labs, there will be 2 different asks. One is we will have a set of sort of assigned variants with evidence to ask labs to go through to kind of more see, does the logic make sense as far as are things being applied consistently, but then also ask labs for a week or so for the variants that you're assessing normally with your current framework. Also, try it with this guideline and see, are there differences? Are there variants that are getting to a much different classification, and be able to give us that kind of feedback as well about what you're seeing compared to your classification as you would be doing it now.
Anna Miller.
Right, yes, I'm just wondering if you could comment on how these guidelines allow you to get to likely pathogenic using only in silico tools.
So they wouldn't get to likely pathogenic with only in silico, because right now in silico would get up to at max +4 points, which is still in the VUS range. So in order to get to likely pathogenic, the other evidence would have to come from clinical data or other pathogenic variants that were also within that codon. That other data would be needed, that silico on its own would not get to likely pathogenic.
All right, question from the chat. Do you have advice for VSEPs that are looking to update previously published versions of their guidelines in terms of adapting with current recommendations, or stop and start and wait for version 4?
Yeah, that is a good question. Yeah, for ones that have already worked, I mean, I do think that a lot of those, again, those concepts they've been working on will still be applicable for the next version. It may be structured a little bit differently. Yeah, at some point we on the ClinGen side with an SBI need to decide at what point we, give more structured feedback as far as, okay, if at this point, if you haven't yet started, maybe it would make more sense to wait a little bit longer. But again, it's all the same evidence types in the next version, that those aren't going away, that we hopefully we'll have better guidance about how to do those leftovers when we get a little bit closer.
And I think the most work that the VSEPs go through are trying to decide what are the clinical phenotypes that lead to what evidence levels, and what are the functional assays, what are the allele frequency thresholds, like all of those decision-making are still relevant to the new framework. It's just that you'll have different codes and different points that for each of those decisions. But honestly, I think the hardest things our VSEPs go through in terms of coming up with decisions will still be relevant.
Yeah.
One point that I will raise out of the chat, there was a suggestion as you're piloting to also take a look at how much time it takes people to utilize these new guidelines versus the old guidelines. Something people are talking about in the chat in case you did not see it.
Yeah, that will be, I mean, imagine that they will take longer, at least initially.
Absolutely, you're not familiar.
I'm familiar with it, but yes, that's a great point to address.
I was thinking kind of an advocacy to the labs that cannot afford a very sophisticated informatics pipeline to do this, right?
Yeah, and in a way, we're hoping that with points, this point approach in a way would also somewhat be easier because it will be a little more, I mean, hopefully easier to build if it's a +1 here, +2 here, +3. That'll be a little easier than me. Okay, if I had 3 strongs and this, we're hoping that it would be a little easier to implement, is what we're at least hoping.
And I will say, like, you know, when you see all these like decision trees and flow charts, it can be a little overwhelming to anyone, you know, seeing it from a distance. But one of the things that we're hoping is that it takes a lot of the subjectivity out of it. And it's literally like doop, 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 points, doop, doop, doop. You're like even though there's a lot more there, like making decisions about, well, there was no guidance around how much points to award or what level for segregation, I have to make it up myself, or there's no guidance around double counting across these different codes, so I have to make it up myself. Like, so even though there is a lot more sort of guidance and documentation and decision trees and stuff, we hope it actually flows quickly, and once you get used to it, I don't think we should time anybody in their first 10 variants, but we do hope that it actually makes it easier, but it's to be seen.
I'd like to add that criteria specification registry, which currently works for version 3, will be upgraded to version 4, and it will have an editor for VSEPs, but also APIs to tap into by local lab tools or variant interpretation infrastructures, and also websites like Decipher now using criteria specification registry to present it on their website. So we are creating infrastructure to allow application of these new guidelines easier by others, not just ClinGen.
But just so that, because not everyone totally understands all our tools, the criteria specification registry is only for those genes that have expert panel developed specifications, which is still a very small number of genes. So the major source of support for the rules will have to come from either the ClinGen variant curation interface, which eventually will have support for this, but it won't be on day one, as well as everyone else's systems, whether they be commercial or in-house built systems, unless you want to just walk along the flowcharts.
CISPEC registry will support all the rules that are in VCI. In fact, VCI will use CISPEC registry as a source of information about rules.
When there are specifications.
Right.
The most genes won't have it.
Stephen, do you want to talk a bit about non-coding variant classification? So someone in the chat is wondering if a separate guideline is under development or if thoughts about that are going to be integrated into this update.
So Nikki Whippen, who had led that effort, I think that's probably the guideline they're talking about, is part of our ACMG work group as well. We have felt like there is, we maybe need a little more data about non-coding variation over time to be able to put it more into our framework. So in this next version, we may point to that publication, but not have anything that is more granular. But that isn't it we have teed up for, this would be a great update for a 4.1 or 4.2 to be able to take non-coding and have it be its own decision tree that you could then, plug into the other decision trees and have that as a comparison. So this 4.0 probably will not have much for non-coding with regards to, UTRs. For splicing, intronic, those would, fall within a lot of what we're doing right now.
But Stephen, I think to some extent, the way that we're laying out the rules makes it so that the apparent effect of the variant is only one part of the rules. You can still apply your phenotype codes, your, observation codes. And so all of those other rules will apply perfectly well. I think it's a question of the, what kinds of predictors can be used to, assess the possible impact of a non-coding variant and wherever it may lie, right?
Yeah, that's a great point. That it is more the points for the variant type. The whole framework would still work. It's just determining the applicable points for that variant type. That's a great point.
Another question from the chat about whether or not there's been any discussion between harmonization between somatic and germline interpretation groups where applicable.
Yeah, so this is Dmitry. So I put the answer to that question. So currently where ClinGen CGC weak SOP is version 1.0, it actually uses a point system, which is very, very similar to the one that we discussed. But of course, V4, germline V4 brings many other aspects. And we'll look in the future for adjusting somatic version, taking today's discussion into account.
And every time people type stuff, it moves my questions all over.
Steve, there have been questions about Denovo getting more points, more
That's
weight.
the one I was trying to find.
And questions about Denovo getting less weight. So do you just want to comment on Denovo?
So the difference, which I should have made that a little more clear, is for those de novo occurrences, they also are getting a point under the case observation. So the way we selected the points for de novo, when you sum it with the points that case will also get under observations, reaches the same strength as de novo in the 2015 guideline. So for example, that +3 for confirmed, that case would also be getting a +1 under the case observations. So in total, it still would end up being 4 points for that case. It's just now structured a little bit differently. We, at least for the case observations, we kind of have all the cases first going through kind of this generic rubric of the based on the phenotype, and then additional components for if it's de novo or a highly specific phenotype that would be add-ons to sort of that starting sort of baseline points it would get from just being a case.
Okay. Here's another one. Another risk would be that of development of automated tools with several labs relying their classification only on these publicly available tools without manual reevaluation, which already appears the case with current guidelines. Could you include a recommendation for or rational use of these tools? And I'm guessing that's just referring to third-party tools that get created sometimes with or without our input on how things are being interpreted. Do you have any comments on that?
Yeah, so I mean, the 2015 guideline made the point, which we will also reiterate in the next version, is that in the end, a classification should be based off all evidence. And so a lot of these tools can only automate so much of the guidelines, maybe the allele frequency or, predictors or things like that, that in the end, that classification, you need to look at everything to be able to, reach a confident classification. So it is something that we can reiterate that, there are certain parts that are, more prone to automation that will definitely be helpful to have automation in there. But it still won't work for every variant type or all types of evidence, I mean.
But also just the point that was being made, there are software systems out there that do not correctly apply the current rules, and I'm sure will not correctly apply the future rules. And it's incumbent upon all of us to help point these things out to these platforms, tell them when they've gone awry, and also make sure that we're validating what rules are being applied and can they be applied, and cross-checking that it's been done correctly, because yeah, this stuff is not fully automatable.
I would like to add that at least for those genes, as Heidi points out, that are curated by ClinGen, we will have APIs for programmatic access to criteria specification registry in computable form, so that these rules can be imported into local systems. But also we'll have a pathogenicity calculator, which was published previously. We'll have a new version where these rules can be semi-automatically applied, but this is still going on. Development is in progress. We expect release next year.
Wes.
Hey, Heidi, I was curious, within resources like ClinVar, right? And I brought this up to you a little bit at AGBT. What kind of work is being done on providing like structured phenotype fields? Because I think this is something that a lot of us struggle with, is being able to, munge through all of these papers and databases to try to identify what phenotype even matches, this variant. And so, oftentimes I think people look to ClinVar as kind of like the exemplar. So is there anything going on right now to try to have some more structured phenotype data for submission? What's the progress there?
So, I mean, I think it's important to just remember that ClinVar is primarily a database of classifications, and although you can support case level data in support, so there's a separate tab that you can upload case observations that can be then connected to your classification, that the vast majority of labs do not actually utilize that structured case observation data. Some will put in like 3 cases, they'll put a number in the variant classification to say we've seen it in this many, but even that is not commonly used. I think we're even struggling to get labs to, when they make a classification, to consistently use a disease name for that pathogenicity claim. And anybody who's used ClinVar knows that, you know, the disease names that are put in there mostly are not provided, is probably the most common one. And then what they use otherwise is highly variable. So this is a huge area that our field needs to deal with. Honestly, I think what we need to work on, and one of the reasons I spent a lot of time in Global Alliance for Genomics and Health, is ways we can share case level data with HPO terms and Mondo ontology and as much structured data on the genotyping and phenotyping side, which will be absolutely critical to actually inform all of our analytical pipelines for doing genomic analysis and interpreting causal variation. But, you know, ClinVar is more of a database of classifications. And I think it's done a wonderful job for that, for our field, but it's not really optimized for case level data, if that makes sense.
All right, we have come to the end of our time. So just to sum up the action items, so this call was recorded. You will be receiving a link to the recording in the next few days to the ClinGen All listserv. Stephen, there has been a request, if it's possible, for you to do a PDF copy of the slides, and we can maybe attach that as well when we send out the link for people who can't get to Google Drives. And if labs are interested in helping pilot, was there a sign up link, or you would just like them to email you?
I had put an email in the slides, and I think I put it in the chat. It's the ACMG_SVC@clinicalgenome.org. So that'll be in the slides.
That'll be in the slides, and we'll send those to you within a few days. So thank you everyone for your attention, and we will talk to you again in about a month. Have a good weekend.
Thank you.